Documentary. Air India's fleet is entering a new era with the arrival of the Airbus A350, one of the most advanced passenger aircraft ever built. This long-haul wide-body jet represents the future of aviation. Made with over 50% composite materials, the A350 is lighter, stronger, and far more fuel-efficient than earlier generations. Its wings, curved like the tip of a bird, flex during flight to reduce drag and save fuel. Step inside, and passengers notice the difference immediately: wider seats, quieter cabins, and cleaner air systems that reduce fatigue on long journeys. For airlines, the benefits are just as powerful: lower operating costs, reduced emissions, and greater reliability. For Air India, adding the A350 is more than just updating its fleet. It is a signal to the world that the airline is ready to compete on the global stage, offering travelers the same comfort and efficiency as leading carriers worldwide. Behind the scenes, assembling an A350 is a massive undertaking. Thousands of parts arrive from facilities across Europe, brought together in one enormous final assembly line. Here, engineers and technicians work in perfect coordination, piecing together wings, fuselage, engines, and advanced avionics. Every bolt, every panel, and every system is checked again and again before the aircraft ever touches the runway. The result is a flying machine that not only carries hundreds of passengers across continents, but also represents the pinnacle of modern engineering. The Airbus A350 is more than just a plane. It's a glimpse into the future of air travel. If the Airbus A350 shows us the future, the Boeing 787 Dreamliner proved it was already here. Built for airlines like Jetstar, the Dreamliner revolutionized air travel when it first took to the skies. What makes the 787 so unique is its design philosophy. Like the A350, it uses lightweight composite materials. But Boeing pushed the boundaries even further. Nearly the entire fuselage is made of carbon fiber, making it significantly lighter than aluminum-based aircraft. The result? Fuel savings of up to 20% and the ability to fly long routes more economically. But efficiency isn't the only story. Inside, the Dreamliner redefines passenger comfort. Larger windows that dim electronically, higher cabin humidity, and lower cabin altitude all help reduce jet lag. These innovations may seem subtle, but for passengers crossing oceans, they make all the difference. For airlines like Jetstar, the Dreamliner is a game changer. It enables long-distance point-to-point routes that once required a stopover. That means more destinations, lower costs, and a more competitive edge in the airline industry. The 787 Dreamliner didn't just modernize air travel, it reshaped it, setting new standards that competitors had to follow.
Documentary. While wide-body aircraft dominate long-haul flights, narrow-body jets like the Airbus A321neo are the workhorses of short and medium-haul travel. Turkish Airlines' new A321neo ACF, or Cabin Flex, introduces a clever redesign that maximizes efficiency without sacrificing passenger comfort. By repositioning exit doors and optimizing cabin layout, the aircraft can carry more passengers while still offering the space and comfort the travelers expect. For airlines, this flexibility is critical. More seats mean greater revenue potential, while the advanced engines and aerodynamics of the A321neo deliver impressive fuel savings. For passengers, it translates into affordable fares with a modern onboard experience. The A321neo ACF shows how even small design changes can have a huge impact on the economics of aviation, keeping flights efficient, comfortable, and sustainable.
In 2012, the skies above London carried more than just athletes and spectators. They carried a message of pride. British Airways unveiled a special livery to celebrate the London Olympics, turning an ordinary aircraft into a flying symbol of the Games. Custom liveries like this go far beyond paint. They require detailed planning, precision application, and thousands of man-hours to transform the fuselage into a canvas. Every line, every color must be exact, not only for aesthetics, but also for aerodynamic performance. For passengers, boarding such an aircraft is a unique experience, a reminder that aviation is not only about transportation, but also about culture, identity, and national pride. The Olympics livery showed how airlines can connect global events with the magic of flight, making the aircraft itself part of the celebration.
Documentary. While wide bodies often grab the spotlight, the Boeing 737 remains one of the most successful aircraft families in history. The 737 MAX 7, the smallest of the MAX series, is designed to continue that legacy with cutting-edge technology and improved efficiency. The production process begins with giant fuselage sections transported across states before arriving at Boeing's assembly plant. Here, thousands of workers and advanced robotics bring the aircraft to life, installing wings, attaching the vertical stabilizer, and carefully wiring the complex avionics systems. What sets the MAX 7 apart are its advanced LEAP 1B engines, redesigned wingtips, and updated aerodynamics. Together, these features reduce fuel burn, extend range, and lower carbon emissions. The aircraft can fly farther than previous 737s, opening up new routes for airlines without needing a larger jet. Yet the story of the 737 MAX is not without controversy. Grounded for nearly 2 years following safety issues, Boeing faced intense scrutiny and was forced to make major design and software changes. For the MAX 7, these improvements are built in, ensuring compliance with the highest safety standards. For airlines, the MAX 7 offers flexibility, the ability to serve smaller markets while still enjoying the efficiency of the MAX family. For passengers, it promises a quieter, smoother, and more modern flight. This aircraft is both a continuation of Boeing's best-selling line and a reminder of the industry's relentless push for safer, more efficient skies. If the aircraft is a body, then the engine is its beating heart. And for the Boeing 777X, that heart is the GE9X, the largest and most powerful jet engine ever built. Standing taller than a giraffe, with a fan diameter wider than many passenger cabins, the GE9X pushes the limits of engineering. Despite its size, it is remarkably efficient, consuming less fuel while producing lower emissions than previous engines. Inside, cutting-edge materials like ceramic matrix composites withstand extreme temperatures, while advanced fan blades reduce drag and noise. Each engine undergoes exhaustive testing, exposed to freezing cold, desert heat, and even simulated bird strikes to ensure flawless performance at 35,000 feet. For the 777X, the GE9X is what makes ultra-long-haul flights possible. More range, more passengers, and less fuel per mile. It represents not just power, but the future of sustainable aviation, where bigger doesn't mean wasteful, but smarter and cleaner. Documentary. Every airplane, no matter how advanced, eventually needs a fresh coat of paint. And when it comes to a giant like the Boeing 777, this process is a massive operation in itself. The work begins by stripping away the old layers of paint, carefully removing hundreds of pounds of material without damaging the aircraft's aluminum skin. Next comes surface preparation, smoothing, cleaning, and applying protective primers to guard against corrosion. Only then does the artistry begin. Teams of specialists spray on layers of paint, carefully masking logos and details to create the airline's identity. Precision matters. Paint adds significant weight to the aircraft, so every coat must be applied evenly and efficiently. The result is more than cosmetic. Fresh paint protects the structure, reduces drag, and even improves fuel efficiency. When the job is done, the aircraft doesn't just look brand new, it's ready to return to the skies with both beauty and performance. Not all work inside an aircraft hangar is glamorous, but some of it is absolutely vital. The rear spar of an Airbus wing is one such example, a structural component that bears enormous stress during every takeoff and landing. For easyJet, engineers performed a detailed service bulletin on this critical part, ensuring the aircraft remained compliant with the highest safety standards. The process requires precision and patience. Technicians dismantle panels, inspect hidden areas for signs of fatigue or corrosion, and replace or reinforce key structural elements. These tasks are not just routine checkups, they are mandated by manufacturers to ensure long-term safety. Skipping them is not an option. It's the unseen side of aviation, the part passengers never witness, yet it's what keeps every flight safe. When completed, the aircraft emerges structurally sound, certified for thousands more hours of reliable service. This kind of work shows the depth of care that goes into each airplane, proving that maintenance is as critical as manufacturing when it comes to keeping the world flying. Documentary. While new aircraft roll out of assembly lines, older planes are kept flying through intensive maintenance. One of the most fascinating examples is the Boeing 757 of Titan Airways, undergoing a major service at Monarch Aircraft Engineering. Unlike routine daily checks, this is heavy maintenance, often referred to as a C check or even a D check. Over the course of weeks, engineers disassemble large sections of the aircraft, removing seats, stripping interiors, inspecting wiring, hydraulics, and structural components. Every system is examined. Landing gear is tested and refurbished. Engines are inspected down to the smallest turbine blade. Cabin components are replaced or upgraded, from seats and galleys to lighting and safety equipment. The airframe itself is checked for microscopic cracks or corrosion that could affect long-term integrity. This level of work costs millions and grounds the aircraft for extended periods, but it is absolutely essential. Commercial aviation's incredible safety record comes from this very process: meticulous, regulated, and uncompromising. For Titan Airways, this overhaul not only extends the life of the 757, but also ensures it continues to operate with the same reliability as when it first entered service. To passengers, it may look like just another airplane at the gate, but behind the scenes, it has been through a rigorous transformation, rebuilt, recertified, and ready to fly thousands of hours more. Heavy maintenance like this is a reminder that airplanes are not just machines. They are living systems, constantly renewed through the dedication of engineers and technicians who ensure that every journey begins and ends safely. Every flight begins and ends on the strength of an aircraft's landing gear. On the Airbus A330-300, the main wheels and brake assemblies play a critical role in ensuring safe landings, controlled deceleration, and reliable ground operations. But like all high-stress components, they require periodic removal and replacement, a process known as R&R. The procedure starts by lifting the massive aircraft on hydraulic jacks, suspending it safely so engineers can access the landing gear. Each wheel weighs several hundred kilograms, fitted with tires designed to withstand the shock of touchdown at nearly 170 miles per hour. Technicians begin by removing the wheel assembly, disconnecting hydraulic lines and brake units with absolute precision. The brakes themselves are remarkable pieces of engineering. Multi-disc carbon systems capable of absorbing enormous amounts of energy during landing. Over time, heat and wear demand replacement to maintain performance. Once inspected, refurbished, or replaced, the new wheel and brake assemblies are carefully reinstalled. Torque settings, hydraulic connections, and alignment must be perfect, as even the smallest mistake could compromise safety. Finally, a full system test ensures proper brake pressure, hydraulic flow, and wheel integrity before the aircraft is cleared for service. For passengers, this work is invisible, but without it, the A330-300 could never operate safely day after day. The main wheel and brake R&R reminds us that aviation safety is built not only in the skies, but also on the ground, in the meticulous work of engineers who ensure that every landing ends exactly as it should.